Okay, and it's my great pleasure to introduce today's speaker for our PRISM seminar, Professor Dennis Feehan, who's joining us from Berkeley. And I guess we should be particularly grateful that Dennis is joining us, given that it's 3 hours earlier where he is. Just as a quick intro to Dennis Feehan is an associate professor in the Department of Demography at UC Berkeley. He's a demographer and a quantitative social scientist. Dennis's research interests lie at the intersection of social networks, demography, and quantitative methodology. In the summer of 2015, he finished his PhD at Princeton's Office of Population Research, and he spent the fall of 2015 as a research scientist at Facebook. And today, Dennis is going to tell us about using an online sample to learn about an offline population. So with that, I'm going to turn it over to you. Thanks, everybody.
Great. Thank you so much, Robbie, for that introduction, and thank you for inviting me to join you this morning. I'm really happy to be here. So I'm going to be talking today about this paper on using an online sample to learn about an offline population. And this project was a joint work with Curtis Cobb, who's at was at Facebook, and I guess now is at Meta. And so I thought I'd start by trying to just kind of frame the problem a little bit. So this is a situation that I think many of you might recognize. Let's suppose that we're interested in trying to understand something about a particular population. And excuse me, ideally, we'd like to sample and interview members of this population directly, but it might be prohibitively difficult to do that for some reason. So for example, it might be really expensive. This group might be hard to reach, et cetera, et cetera. But it turns out that it's much easier or more feasible to study people in a related population. So I'm thinking here of, say, people who use the internet, people who have mobile phones, people who have a website, et cetera, et cetera. So I'm kind of interested in trying to understand how might it be that we could sample people in this easier to reach group and learn about a broader set of people. And I'll talk about kind of one big picture approach to how we might do this today. And I think this approach can be useful in a lot of situations, but obviously not in every situation. So this might be useful in some cases. And the idea here is to recognize that people aren't isolated. So everybody is embedded in lots of different kinds of personal networks. And so we can sample people in this group and we can ask them about who they're connected to through these personal networks. And we'll learn something about some people who are in this population of interest who are not, who we can't directly reach. So that's going to be the big picture idea. Try to sample people in this easier to reach group, but ask them about their personal networks in a way that gives us information about a broader set of people. So the specific kind of substantive problem I'm going to look at today is trying to estimate rates of internet adoption. And there's a lot of reasons we should care about this. There's a lot of evidence about the economic benefits of having access to the internet, but we also know that there's a lot of inequality in who gets to use the internet. There appears a lot of inequality both within and between countries. And so policies and researchers measure internet adoption. Unfortunately, measuring internet adoption has traditionally required rigorous sample surveys. And I'm a big fan of rigorous sample surveys, but they do have some downsides. They can be slow and expensive. And we wanted to see if we could develop a method that could produce faster, if perhaps somewhat approximate estimates of internet adoption from an online sample using the kind of logic that I described in this in this picture here. Okay, so then my kind of plan for the talk today is I'm going to give some sort of high level, hopefully intuition building description of the methods. Then I'm going to describe the design of an empirical study where we're going to use these methods to try to estimate internet adoption in 5 different countries. I'll show you the results of the empirical study, and then I'll talk about some next steps and where I think this kind of stuff might go in the future. Okay, so I'm going to start with this kind of high-level conceptual description of the methods. And the idea here, as I said, is that survey respondents are connected to other people through lots of different kinds of personal networks. And so we can ask respondents questions about members of their personal networks. And when we do that, we learn about more than just the respondent herself. The trick here is that we have to figure out how to make use of the information that we get when we receive these reports about people's network members. This idea is fairly natural, and in fact, it's arisen in a lot of different settings. So for example, I was actually first brought to this method because I'm a demographer, and in demography, we have an approach that tries to learn about deaths by asking people about their siblings. There's also a method called network scale-up that's been used to try and study epidemiologically important groups like drug injectors and sex workers. Other researchers have used techniques like this to try and learn about migrants, people who have moved away, and lots of other situations. So there's a lot of different individual methods that have been developed that are based on this idea that you can ask survey respondents to report about other people. And I've been working on this, this kind of framework that I call network reporting, which kind of tries to provide a way to analyze these different methods, to highlight the things that they have in common and what they have different, what they have in how they're different, and then also to allow us to sort of develop new approaches or new methods in situations where there may not be an off-the-shelf method that exists already. So how does this work? I'm going to try to walk through a very simple example to build some intuition about this. So let's suppose we have a sort of toy population like this one with 6 people in it. 4 of these people here use the internet, and 2 of these people are on Facebook. I'm not sure if I've said this yet, but in the application that I'm going to discuss in a minute, the group that we're going to sample is people who use Facebook, and we're going to be trying to learn about internet adoption from the people who use Facebook. So that's why the example here is Facebook. Okay, so we have a simple population here with 6 people. The 4 people in gray here use the internet, and 2 of these people with the blue border, these people also use Facebook. Yeah, and in this picture, we see kind of a social network. So these edges show the connections between these people. And I haven't said yet what it means for people to be connected here. I'm actually going to defer that question for a little bit. So I'll talk about that a little bit later in the talk. But for now, we'll just presume that we have some way of establishing whether or not people are connected. And this simple picture shows the relationship between these people. When we sample the people on Facebook and we ask them to tell us about the other people who they're connected to, this social network turns into what we call a reporting network. So now there's directed edges in this network, and there's an edge from one node to another whenever this node reports about that other node. So you can see that this person number 3 here is reporting about person number 1, person number 4, and person number 2. Now, in general, there could be differences between this reporting network and the underlying social network because people's reports may not be perfectly accurate. But for now, I'm going to kind of assume that in this picture, in this toy example, I'm assuming that these reports line up with the structure of the underlying network. And it turns out to be helpful to kind of reformat this reporting network in the way that I've shown on the right here. So this picture on the right has the same information as this picture on the left, but I've reformatted it so that the nodes that make reports are on the left-hand side here, and all of the nodes that could be reported about are on the right-hand side here. Okay, so that means that every report that's made in this reporting network goes from this left-hand side to this right-hand side. And that turns out to be helpful to just kind of drive home the point that there is this kind of identity that has to be satisfied in this network. This identity, there's different ways you can think about it, but I like to think of it as the total number of out reports. In other words, the total number of reports that kind of leave this left-hand side has got to be equal to the total number of reports that arrive at this right-hand side. That's helpful because that means we can start from this identity and do a little bit of algebra. We could take the number of reports about internet users that arrive on the right-hand side and decompose that into the average reports per internet user times the number of internet users, and then rearrange that, and we get this expression here for the number of internet users. Specifically, the number of internet users should be equal to the total out reports divided by the average number of times each internet user is reported. So the intuition, just to step back for a second, if we just asked everybody, if we conducted, say, a census of the set of people we're sampling, and we asked them to report how many people in their networks were internet users, we added all the reports up, we'd get a number that was too big because each internet user could be reported by more than one person who we're interviewing. So to adjust for that fact, we have to divide by the average number of times that each internet user gets reported. That's the big picture idea here. So just to make this concrete, in this particular case, the total out reports about internet users, well, person number 2 is reporting two internet users. Person number 3 is reporting 2 internet users. So there's a total of 4. And then if you go through the internet users, the average number of in reports is 1 plus 1 plus 2 plus 0. And so the average is 1. If you take this total out reports and divide it by the average, you get the number of internet users. So that's the kind of, obviously this is a very simple example, but that's the basic logic of the estimator. So given this kind of logic, the idea is to try and come up with a way to estimate the numerator and then to estimate the denominator of this number of internet users, and that's gonna allow us to produce an estimate for the number of internet users. And I'll start by trying to think through a little bit how we might estimate this numerator, the total number of reported connections to internet users. So in principle, this is a fairly simple thing to do. We have a survey, we're asking respondents questions. We can ask them a question, something like, how many people are in your network? And then which of these people uses the internet? I would say, I wouldn't say we should use exactly this wording, but this is the kind of spirit of what we want to try to get from people. But this sort of begs this question, who should count as a network member? So who should we ask respondents to think about when we ask them to report about their network? In other words, we need to choose a tie definition. So an important question is, how should we think about what type of network to ask respondents to report about? So there's previous research on social networks that kind of has some theoretical predictions that can help us think this through a little bit. So many of you may have heard that this idea that network ties or network relationships can be characterized according to their strength. So there's a kind of spectrum between strong tie relationships, which are sort of emotionally very salient and meaningful, probably on average involve more frequent interaction, and so on and so forth. So somebody like your really close friends or your siblings at one extreme. On the other extreme, we have weak tie relationships, which might be acquaintances, people you sort of would say hi to, but don't really otherwise know very well. Maybe you don't see them as often and that sort of thing. And then kind of everywhere in that spectrum in between, you can kind of come up with different types of relationships that would result in ties of different strengths. So I'd like to think about how varying the strength of the relationship that we use to ask people to report about in the survey might affect the errors or the accuracy of our estimate. So one important perspective, we're on a survey, we have a sample, so there's going to be some kind of sampling error from our estimate. And we know from previous research that strong tie networks tend to be relatively small. In other words, you probably have a relatively small number of very close friends. But weaker tie networks tend to be bigger. You probably have a pretty large number of acquaintances. And an interesting thing about these surveys where you ask people to report about others is that you, in principle at least, you learn about a lot of people from each response. You're not learning about just the respondent herself. You're also learning about all of the respondents' network members, at least in principle. And so from that perspective, when you ask about a relatively weak tie network, you get information about a lot of different people from just one interview. So that means that your kind of sampling error is relatively low. On the other hand, when you ask about a strong tie network, you get relatively sort of less information per interview. And so that suggests that the sampling error is going to be pretty high. So we might conjecture or predict that as we move from asking about a relatively strong tie network, like say siblings, to asking about a weak tie network, like say people you bump into on the street, your sampling error, at least in principle, will kind of go down because you're learning about more people from each interview with these weaker ties. But of course, the other important factor in the error in a survey-based estimate is the non-sampling error. And so here, we also know from previous research that stronger people tend to know a lot more about others who they're connected to through strong ties. I mean, I know a lot more about my sibling than I do about somebody I bump into and say hi to on the street. So when I answer survey questions about somebody I'm connected to through a relatively strong tie, I think I'll be able to do that on average more accurately than I would be able to do that about somebody I'm connected to in a relatively weak tie. So that sort of suggests that as we move from a strong tie to a weak tie, the non-sampling error we think will probably increase when we ask about weaker tie networks. And of course, what we care about at the end of the day is not just the sampling and the non-sampling error, but we care about the error and the estimate. So we care about how these two things combine to produce total error. And what this sort of conjecture suggests is that we should try to find some kind of tie strength that hits this sweet spot where total error is minimized. Now, just to emphasize, this is like a conjecture or a theory. This is not an empirical fact. These two curves. So this is sort of a prediction to think through how maybe we should go about trying to answer this question. But I don't know for sure that the shape of these curves have exactly this shape. And ultimately, it's an empirical question. What sort of tie produces the most accurate answers? And that's something, part of what I'm going to try to think about today in our talk is how we can start to answer that question.
Dennis, can I ask you, interrupt to ask a quick question about the previous slide? I guess one thing that occurs to me is it seems like maybe the kind of ties might characterize sort of just different substantive questions. Like you may be interested in fundamentally interested in networks where there are stronger ties or weaker ties. And so I'm curious, like what if the sort of network that corresponds to the tie that minimizes the total error just isn't something you're that interested in?
Yeah, well, so I guess in the case of this study that I'm talking about here, the networks are instrumental in the sense that what we're interested in is trying to estimate the rate of internet adoption. So in our case, the choosing the network was a study design parameter, basically. So not a core interest. Obviously, in another study, you might actually have a substantive interest in a specific network and therefore really want to ask about that specific network. So then I guess you're probably not in the world where you're making a decision about which network to ask about, and so this may not be as relevant. I mean, I think that these trade-offs would still apply, and it may or may not be that you can estimate a given group with the network that you're collecting data about. But yeah, I guess this framework was more about the situation where you're interested in measuring something and you want to choose a network to do that as effectively as possible.
Thanks.
Good question. Any other questions? Well. Okay, great, cool. Well, again, feel free to, yeah. Okay, so to try and start to get a sense of, sorry. Okay, so there's been a little bit of previous research about this potential trade-off, and there's been and it's found some evidence of this this kind of relationship where there might be a trade-off between the tie strength and the accuracy of the estimates that get produced. And so the empirical study that I'm going to talk about embedded an experiment in it to kind of further test this question in our setting. And the experiment randomized respondents to report about one of two different types of network. This first network I'm going to call the conversational contact network. And the sort of the prompts that was used in the survey was, how many people did you have conversational contact with yesterday? By conversational contact, we mean anyone you spoke with face-to-face for at least 3 words. This is like the day before the interview yesterday. So this definition comes from epidemiological studies that have used a question like this to collect information about contacts in order to help disease modelers parameterize the number of contacts that people have relevant to transmitting infectious diseases. We're obviously using it for a different end here, but there's a fair amount of data that exists with this kind of network question. And so that was we sort of wanted to start with something that we could compare. We had some comparisons for. And then half of our respondents were randomized to report about a different type of network, which I'm going to call the meal network. So this network prompt says, how many people did you share food or drink with yesterday? These people could be family members, friends, coworkers, neighbors, or other people. Please include all food and drink taken at any location, including home, at work, or a cafe, or in a restaurant. So the idea is that we think that this will, on average, be a stronger type of relationship, somebody you have a meal with, as opposed to somebody you just bump into. And so kind of consistent with the framework I was describing in the previous slide, we think that people will tend to have somewhat fewer connections through this meal network, but we think that people will may be able to report more accurately about the characteristics of these people that they shared a meal with. And so and this network, this tie has not, as far as I know, been used in previous studies. In a study that I conducted in a different context, we used a network kind of like this one, but the time window was much longer. This is just asking about meals the day before the interview, so yesterday. So I think this has not been collected before. Okay, so so I'm going to kind of try to, so we took a little detour and talked about this idea of how we have to choose a tie definition if we want to use network questions like this to estimate the size of a group like internet users. Now I'm going to go back to providing some intuition behind how the actual estimator works. So let's suppose, you know, we're in the arm of the experiment where we're asking people about this meal definition. We ask a survey respondent something like, how many people did you share food or drink with yesterday? And the respondent tells us, the response the respondent gives us tells us about her network size. So let's suppose the respondent says 6. I shared food or drink with 6 people yesterday. That tells us this respondent's network size. And now we'd like to sort of try to figure out what proportion of the respondent's network members use the internet. So ideally, we'd ask the respondent about every person in her network one after another. This is something that some network survey questions do. On the GSS, for example, they do something a little bit like this with name generators. And you know, that's a reasonable approach. But in this case, it seemed like this would be really tedious for respondents. We're going to be asking these surveys on Facebook, so people are, we don't expect that people are going to be willing to spend a lot of time in this survey. And we thought that asking about every single network member one by one would result in unacceptable levels of fatigue and people breaking up the survey. So instead, we ask respondents about a subset of their network contacts that we call the detailed alters. So we ask respondents to provide sort of in-depth information about the 3 of their network members, the first 3 network members who come to mind. And we're gonna, in the actual estimates, we're gonna treat these 3 detailed alters as though they were a random sample of the respondent's personal network. So that's probably not exactly right. In reality, it's probably the case that some network members are likely to come to mind more readily than others. So in the paper, we talk about how that kind of thing might affect the estimates. And to some extent, we can, but I'm not gonna go through the details of the sensitivity framework in the talk today. And then I'll show you, though, in a little bit that we can also kind of check some of the assumptions of this estimator empirically to get some sense of whether or not this is a big concern. Okay, so that's a little bit about the numerator of this expression. We talked about how we can try to choose what type of network we want to ask respondents to tell us about. And then once we fix the network, I sort of gave you hopefully a high-level idea of how we get the information we need to estimate the total number of reported connections to internet users. Now I'm going to talk about this denominator, which is the average number of times that an internet user gets reported. So you can, if you think about this for a second, you could probably imagine a lot of different ways to kind of approach estimating this quantity. We chose something really simple in our study. And what we're going to make the assumption that people who have internet access don't pay attention to whether or not they're on Facebook when they share meals with one another. Okay, so we're assuming that among people who have internet access, connections are not formed, meals are not shared based on whether or not people have Facebook. So to be a little more precise, our assumption works if the following 2 quantities are equal: the rate at which people on the internet share meals with somebody who's on Facebook, and the rate at which people who are on Facebook share meals with somebody else who's on Facebook. So again, the paper has a couple of simple models that show when this when we would expect this kind of assumption to be satisfied and when we wouldn't. And I'll talk a little bit later in the talk about a way that I think we can maybe relax this assumption in the future by collecting some additional data. But for now, we're going to assume that the people who are, we're going to assume that these 2 quantities are equal. In other words, that people don't pay attention to whether or not they're on Facebook when they decide whether or not to share meals together. And this is, in this second quantity, we can estimate directly from our survey responses. And so that's what we're going to use to approximate this visibility. Okay, so putting it all together, I talked a little bit about this numerator and the denominator. And I tried to highlight the kind of what I think of as the 3 key conditions that we need for this approach to work well in principle. I need these detailed alters, the 3 people respondents report about, to be chosen like a random sample from their network members. the assumption I just mentioned a second ago, I have to assume that meals are shared between people without paying attention to whether or not they're on Facebook. And then I'm also making the assumption that reporting about the network members is accurate. I put an asterisk there because there's a kind of, and the paper has a sensitivity analysis that sort of describes how different types of reporting errors would affect the estimates. And it turns out that a certain amount of inaccuracy is actually not a big problem for the estimator as long as it's not correlated with internet use, Facebook usage. So so in other words, in some sense, systematic, noise in the numerator and the denominator can cancel in a lot of situations, I guess is what I'm trying to say. If you kind of look at the sensitivity framework, you see that we don't need every single report to be exactly accurate. We need, on average, for reports to be accurate, which is a somewhat weaker condition. So anyway, you can look at the paper for the sensitivity framework if you're curious about that. Another nice thing about the sensitivity framework is that it kind of shows how these conditions might be relaxed if we can collect additional data, and I'll talk about that a little bit more towards the end of the talk. Okay, so now let's start to look at some results. So just to give you a sense of what these results come from, we have a random sample of Facebook users in 5 different countries. We obtained this random sample using Facebook's internal survey infrastructure. They have a kind of whole framework for taking surveys of the people who use Facebook. This was a very short survey, and it could be taken over web or mobile. I looked at a lot. I spent a lot of time, developing weights, calibrating, post-stratifying, et cetera, et cetera. In the end of the day, these approaches really didn't matter to the estimates very much because we have what seems to be a pretty representative sample of Facebook users in these countries. And there's you'll see in some estimates confidence intervals, and those are capturing the sampling uncertainty. Okay, so this plot describes the composition of our sample. We have respondents in Brazil, Colombia, Great Britain, Indonesia, and the United States. Notice that the sample in Great Britain is smaller than the others. This was kind of like a pilot study that we ran first before we ran the rest of the study. And the bars here show the kind of gender breakdown, males and females, and then the x-axis of these panels here is the age category. Basically, these distributions look pretty similar to Facebook users in each of these countries. So we were pretty happy when we saw this. We think that this is a relatively representative sample of the users of Facebook in these countries. Obviously not of the population in these countries, but of the people who use Facebook in these countries. Okay, so now I'm going to start by kind of showing you some plots that describe the estimated degree, the reported degrees using the 2 networks. Remember, we have this experiment where people were randomized to report about the conversational contact network or the meal network. And I'm going to kind of, just to preview this, I'm going to sort of walk through one panel, and then we're going to look at all of them together. And I'm going to kind of follow that template for a few of the plots that are going to come up here. So, so this first plot shows the distribution of reported degrees using the 2 different networks from respondents in Brazil. So that the purple bars here in the top row are the conversational contact network. The orange bars in the bottom row here are the meal network. And there's a kind of couple of and I should say these plots are top coded at 30, meaning like responses that are 30 or bigger are all plotted at 30 here. So you can see that there's a lot of people who report more than, or at least 30 conversational contacts. And so there's a kind of, right away, just by looking at this first set of results from Brazil, there's a couple of things that might kind of leap out at you. So one is, and this is the average. This is the estimated average, this heavy black bar here. So one thing is that the conversational contact network on average is bigger, which is sort of that's what we were hoping to see. That's how we designed these 2 different ties. So that's something we were expecting to see. And then also, if you kind of look at this for a minute, you might notice that this pattern of what's called heaping looks like it's kind of more pronounced in this conversational contact network than it is in the meal network. Not that it's totally absent in the meal network, just that it seems like it's a stronger feature of the conversational contact network results. And that kind of hints at the fact that maybe the responses to this conversational contact question are noisier in the sense that people are kind of estimating more than they are in the meal network. Okay, so then this is the same plot. So we just saw this plot for Brazil. This is the same plot for all of the countries. And what you can see is that the kind of basic idea that we saw in the Brazil plot, I think, sort of holds up across these countries here, in the sense that the estimated average size of the meal network is always smaller. And in all of these cases, it looks like there's at least as much heaping, if not more heaping, with the conversational contact network than there is with the meal network. And then just to give you a sense, the kind of average size of the meal network looks like it goes from about, sort of a little over 4-ish to maybe 7. And the conversational contact networks on average are sort of like 10.5 to 13 people. And that 10.5 to 13 people, that's sort of in the ballpark of estimates that have come from these disease modeling studies that I mentioned that have collected data with this type of network before. So that was the kind of scale of network size here is about what we'd expect from the previous work on this specific tie here. Okay, so now I'm going to take a little detour and talk about what I call internal consistency checks. So what we saw from the degree distributions was sort of consistent with what we predicted, based on this idea that people might provide kind of more accurate information about fewer people through a strong tie network than through a weak tie network. But what we really care about is how those things trade off to produce estimates that are more or less accurate. And so this is one approach to kind of try to get some purchase on this question. And the idea is to try to come up with 2 independent ways of estimating the same quantity from these network reports, and then to compare these independent estimates to one another. And when all of the technical conditions of the estimator are satisfied, these estimators should agree, because they're estimating the same quantity, kind of mod some sampling noise. When the assumptions that go into the estimator are violated, then these estimates might not agree. So these internal consistency checks are kind of a way to assess whether or not some of the conditions that the estimator relies upon have been violated. To make this a little more concrete, both of these network ties that we're studying here are symmetric, meaning that if A is connected to B, then B is connected to A. And what that means is that in total, the number of connections from, say, men to women has got to be equal to the number of connections from women to men, just sort of logically. And so we can estimate the number of connections from men to women and the number of connections from women to men using our data. We can estimate these 2 quantities independently, but we know that they should be the same because this network is symmetric. So we can compare how similar those 2 estimates are as some kind of indicator for how internally consistent the reports about the network appear to be. Just again, I'm going to follow this pattern where I kind of talk about one country and then show you the results from all the countries. So this shows the results of internal consistency checks based on gender and age group in Brazil. So for example, so this slide I was talking about just men to women. Now I'm going to be talking about young men to everybody else to young men as a type of connection that has to balance. And so here, these are age categories on the x-axis. This left-hand panel is females. This right-hand panel is males. The colors are the tie definitions. And then on the y-axis here, we have this quantity which summarizes which summarizes the internal consistency check. So the closer this quantity is to 0, the more internally consistent the estimate for each age-sex group is. And so just to pick one point out and illustrate it, this particular estimate here says that meals that everybody else reports sharing with young women minus meals that young women report sharing with everybody else, that quantity is pretty close to 0. So that's pretty good in the sense that if all of our assumptions go through, we think that it should be 0, or at least the sampling-based confidence interval should include 0. On the other hand, here we see that for young men, it looks like young men report more connections to everybody else than everybody else reports to young men. So something is not perfect here. One of our assumptions, at least, has got to be not going through for this particular group here. Okay, so when we look across all of the countries in our sample, we see that in a lot of cases these confidence intervals do include 0, which is what we'd most like to see. But there are some notable cases where there's a suggestion that there's some kind of reporting error, and I kind of tried to box in red the groups where I think that's especially kind of noteworthy. I should say, by the way, I would love to. So one, maybe it's a little easier to explain this with this specific example. I think sociologically this is really interesting. Unfortunately, with our data, we can't distinguish between we can't tell whether it's actually that young men report more connections or whether everybody else is reporting fewer connections to young men. It'd be really cool if we could, because I think it says something about who kind of gets remembered and who doesn't get remembered in these network reports, which is kind of an interesting question. But anyway, I'm not going to be able to talk more about that today. Okay, so these internal consistency checks give us a nice way to kind of see whether or not the conditions that we need to assume in our estimates go through, and give us some sense of they're kind of like maybe a sanity check. You could think of them that way. But they also allow us to compare the two tie definitions. Remember, we're interested in kind of trying to make progress by figuring out whether a stronger tie or a weaker tie seems to produce more accurate estimates. Well, I can kind of aggregate these internal consistency checks by tie and use that as a criterion for sort of comparing whether reports about one tie appear to be more internally consistent than reports about another tie. And that suggests that that tie that's more internally consistent it produces more accurate estimates, and that's sort of helpful for gradually building up over time a picture of kind of what the relationship between tie strength and the accuracy of estimates is. So this panel shows an example of aggregating the internal consistency checks up for Brazil. And you can see, so this is the estimated sampling distribution of this difference from the bootstrap. And you can see that when this mass of this distribution is sort of to the right, that suggests that the meal tie definition is doing a better job of trading off the sampling and the non-sampling error to produce more accurate estimates. If the mass of this distribution were more to the left, that would suggest that the conversational contact definition is doing better. So in this case, at least for the case of Brazil, it looks like the meal definition is producing more internally consistent estimates. When we go to look at all the countries together, we sort of see 3 countries where it looks pretty clear to me that the meal definition is doing better: Brazil, Colombia, and Great Britain. And then the picture is sort of a little bit less clear in Indonesia and the United States, where that it's not quite as obvious that one of these approaches is doing much better than the other, I would say. So kind of taken all together, that's sort of interesting because it means, consistent with what that sort of back of the envelope conjecture was predicting, by actually learning about fewer people, you can potentially produce better estimates if the reports about that smaller number of people are more accurate. So that's kind of that's sort of interesting and useful to understand. Okay, so these internal consistency checks are like a built-in way to assess the quality of reporting, and they're useful for building up a picture of what kind of networks people can report about. We definitely see some evidence of reporting error in these data. It's also suggestive of like differential social visibility, but we can't really identify. We can't be too specific about that, unfortunately. You could also imagine these internal consistency checks forming the basis of part of a more kind of model-driven strategy to estimating these data, because that's sort of like a set of things that need to be true, and so you can kind of base some kind of loss criterion on those internal consistency checks or something like that if you're interested in building a model here. And just sort of substantively, we saw that in at least 3 out of the 5 countries in our sample, the meal reports look like they're pretty clearly more accurate. Okay, so now let's talk about the estimates. This plot shows the estimated rate of internet usage in 2015, which is when these data were collected, by country here. And again, the colors are the different tie definitions. And the kind of first thing that leaps out to me is that the estimates are pretty similar between these 2 tie definitions. And then also note that the sampling variance is pretty low. And that's actually something I find in a lot of these kind of network reporting type studies. Although you have to worry a lot about non-sampling error, the sampling error is not, because you get this effect of, in principle, at least, learning about all the people in respondents' networks. Sampling error, relatively speaking, is not as big a concern as non-sampling error typically in these kinds of studies. So the sampling error is not that big, with the exception of Great Britain, which was the pilot study, and we had fewer interviewees there. Okay, so now we wanted to kind of compare these estimates to other information about internet adoption around the world. Surprisingly, I think this has improved somewhat, but in 2015, there were fewer kind of really high quality gold standard sources for understanding internet adoption than you might imagine, but there were high quality surveys in 2 countries, in the US and Great Britain. And there's also a survey in Brazil, which is not pictured here. So let me start. I'm sorry, this must be an old, but so let me start. So our estimates here are a little bit higher than the survey-based estimate from Brazil, but the survey-based estimate from Brazil is based on a pretty small sample. So the confidence interval from the Brazil estimate kind of almost hits our estimates here. And at least in the US and Great Britain, our estimates are sort of right in between the 2 estimates for the US. And our meal estimate, at least from Great Britain, is pretty consistent with the other sources of estimates from that country. So, so in sum, it looks kind of like, we can't super rigorously evaluate these estimates, but when we compare to other places, they look pretty similar. Maybe they're a little bit, in the case of Great Britain, our estimates might be a little bit lower, especially the conversational contact definition. We definitely saw that the internal consistency checks revealed evidence of reporting error. So this is something that could be addressed in the future with some modeling, or by continuing to explore different tie definitions to try and see if maybe another type of network produces information about, more accurate information about other people. And then if you're kind of interested in what effect all of these different conditions have on the estimates, the paper tries to work through some of that with the sensitivity framework. Okay, so now I think I'm almost done. I just want to say a quick word about where I think this might go in the future. So I think that understanding this kind of trade-off is potentially really useful. I've sort of been involved in designing a few studies like this where we try to use network reports to estimate something, and this issue of which network we should ask about is a really important one in designing these studies. And just to kind of maybe elaborate this a little bit, in addition to kind of the strength of the tie, another thing we could think about varying is the time window that we ask about. And a few other studies have, let me just kind of speed up a bit. A few other studies have done this. So this study that I talked about today was looking at a very short time window, just the day before. Some network scale-up studies have kind of varied the strength of ties across reports about a really long time window, like interactions in the past year. I have another paper based on some data that we collected using a household survey in Hanoi, Vietnam, and we kind of vary both the time window and the tie strength a little bit. But I think kind of getting a little bit more empirical information about what the relationship between tie strength, the time window, and the accuracy of the estimates is would be really helpful. And if we could have a kind of good theory of this, that would be extremely useful in designing these studies, and might also tell us something sociologically pretty interesting about how people think about their network numbers. And then finally, just to kind of wrap up with this big picture problem, what I did today was kind of show how we can use an online sample, make some assumptions, and produce an estimate that is fast, expensive. It's very easy to experiment when you collect data like this because the instrument is all, it's very easy to embed experiments in a computer delivered instrument. You could potentially get these estimates with a really high time resolution if you wanted to collect these surveys all the time. But I had to make a bunch of assumptions, and these estimates are approximate. If you think about a more conventional kind of high quality probability sample, we get what we hope is a high quality estimate, but it can be relatively slow and expensive. Critically, though, we could start to collect probability samples that collect information that could help these online estimates. So for example, that assumption I needed to make about people sharing meals at the same rate, whether they're internet users or Facebook users, that's something you could ask questions about that on a high quality probability sample and not have to make that assumption, because your probability sample would include, people who are on the internet, people aren't on the internet. And so you could kind of imagine pairing these different approaches together, and you might get something that's sort of greater than the sum of their parts. So you could imagine sort of rarely collecting expensive, high quality probability samples, and then sort of frequently collecting online samples and trying to pair those sources of information to produce sort of high time resolution estimates that try to blend the benefits of both of these approaches. And if you think about it, this is actually a little bit like what we do now with probability surveys and the census, just on a kind of different time scale. We have a census every 10 years and we do probability samples every couple years. Well, this is like you could do a probability sample every couple years and online samples sort of, every other day or something, depending on what you're trying to study. So that's one direction I think that this kind of work could go in. So for this project that I talked about today, you could obviously, I didn't do any modeling here, and that's obviously a direction you could go in. It'd be really interesting to do. You can also explore kind of calculating estimating internet adoption using more detailed characteristics. I just showed you the kind of top line estimates of internet adoption, but you could also use our data to produce sort of age and gender specific rates of adoption estimates. We also, I didn't talk about this, but we collected some data that allow us to try and get at reporting adjustments. So for example, we asked respondents some questions about how aware they think their network members are that they use the internet. We did those adjustments based on those responses didn't end up making a very big difference to the estimates, and so that's kind of why I didn't. But there's some information about that in the appendix of the paper if you're curious. And then kind of I have some related work about this broader topic of network reporting and asking people to report about others in their network. I think I mentioned the sibling histories, which is this old problem in demography that I've been working on. Big study in Brazil where we're looking at estimating adult death rates using reports about people's networks, which is something that's especially important now with everybody trying to estimate excess mortality from the pandemic. I mentioned this Hanoi study, which is another kind of methods paper and a related topic. And then I think we generally need a lot more guidance on sampling and study design in this area. So you could check, so thanks to my collaborator, again, you can check out the paper if you're curious. And if you related papers, there's a little more info on my website. I'd be happy to take questions or chat about this. Thank you.
Thank you so much for such a great talk. So if there are any questions, you can feel free to throw them in the chat and I can read them out loud, or just unmute and we can get to those questions.
Dennis, this is Pat Schrout. Very interesting talk. Can you comment on how gender norms in some countries, and particularly, say, Islamic countries where perhaps the men and women don't interact much beyond the family, how those would affect your estimates?
Yeah, that's a really good question that has come up in other settings. I can't do anything other than speculate about that right now, but I can actually say, so one thing I didn't mention is I have, I'm collaborating with some researchers in Bangladesh. We're collecting data sort of similar to these data in the sense that it's about people reporting about network members. Here we're focused on, again, trying to estimate death rates. And as a result of the kind of study design that we went through, talking to people and figuring out what made sense, we're actually randomizing people to report about either like a sort of general network, and we're going to compare that to an arm where men are asked to report about men and women are asked to report about women. And I think it'll be interesting to kind of see if we can learn anything about that interesting question from those data. So I don't know yet, but maybe in a year or 6 months I'll be able to say something more about that, at least in Bangladesh.
Thank you.
So it's a good question. It certainly comes up when you design these studies.
All right, well, if there are no more questions, I want to say thank you again for a really interesting talk. Thank you again, everyone, for coming, and we'll send out information to the listserv about our next talk when we have that information. And have a great day.
Great. Thank you so much, everyone. Thanks for having me. Bye.